So if you plug that in there, it's going to be 3x's plus 4x's, which makes 7x's. So if 7 times x gives you 7, then x was equal to 1. And then you take that, plug it in there, and y is 4. So you just plug in your, and then you just plug in your ordered pair. Do you want to see the math, or did you get what I did?
No, I did.
Okay, why did it do this? Oh, because it's all small here. And yeah, please be careful. Even though it has those braces, you still have to put in an ordered pair.
Why is the braces there then?
To throw you off.
That's stupid.
To throw you off. Because, yeah, there shouldn't be more than one solution to that. So, is that the only question? Check
So
answer.
you still have to put parentheses?
Yeah, because the ordered pair comes in parentheses, not in braces. Braces are for sets. So what they're kind of saying is, the answer to this is the set of all of these solutions. And technically that's one solution. It's like one number kind of thing, but it's just one set. So that's a good question. All right, let me close this. Anybody need 4?
Do anyone want
5, 6, 7, 8.
Yes.
8. I was waiting for it. It's the final countdown. Okay, and here I think I'm just going to copy these over to the smartboard because it's easier to work on there. There's not enough space in here. Is my camera on? Like, aren't mosquitoes supposed to be gone at this time already?
It rained though. It rained hard.
When it's winter time.
Yeah, well, yeah, it did rain though. So rain always comes back. I love you and I hate you, rain. Okay, now here, my suggestion to you is to use elimination. Okay? What I want to do is try to get this equation, and I want to get rid of the x's. So I want this 2x to become a negative 6x. And how does that happen? Multiply by negative 3. So I have to do it to everything so that I keep that consistency. So there's my negative 6. This is going to become a negative 9y and a positive 3. Okay there?
Wait, could you do it to get rid of the y's?
You could, but that's going to be more work.
Yeah,
But you can, definitely. Definitely. You could, and then probably what you end up doing is multiplying the top by 5 and the bottom by 3. Yeah, it's going to work. I try to do the less work possible. But you'll pick that up as you do more and more and more. You'll start to see what the better option is. Because even though one's already positive, one's negative, which is probably the ideal, isn't it? That's super good. You'll start to see that I'd rather work with a negative in one equation than to mess with all of them. But good job. Okay, are we good here? Anybody need me to keep holding? Sorry, I can't help myself. All right, so I'm going to add the top one with this new version of the second one. 6x minus 6x is 0. That's gone. Negative 5 minus 9 is a negative 14y. And then 39 plus 3 more is going to give me 42. Yeah? And if I both sides by negative 14, this becomes 1. It doesn't go away. It becomes 1y. And what's 42 divided by 14? Is that 3? A negative 3? So there's y. Now, I'm going to take that y, plug it back into one of the first equations. Which one would you choose? The bottom one, because all the numbers are smaller. So definitely. So 2 times x plus 3 times y is a negative 1. And we're saying that y is negative 3. So you guys can see that that's, well, I'll just do it. This is negative 9 equals a negative 1. I'm going to add 9 to both sides. Sorry, had the answer in my head. 2x is equal to 8. Divide both sides by 2 using my division property of equality, and I find that x is 4. So I'm suggesting that the solution is 4 comma negative 3. Don't stop there. Please don't stop there. Especially not on the test. Because if it's not right, then you just did all that work and it could have been something simple like Munoz forgets the negative. You could have gone back and fixed it real quick. So check them. I'm going to use another color. I'm going to check the top one first. 6 times 4 is 24. And then it's going to be negative 5 times a negative 3, which is positive 15. And that has to equal 39. What is it? It's good? Okay. So that's going to get, that is 39, huh? So it works for the first one. Now let me check it with the second one. 2 times 4 is 8. minus 9. That should give me -1, and it does. So that means that my answer, I could take this to the bank. I'm very confident that that's correct, and that's it. There can't be any other options because it's 2 lines, right? It only costs at 1 point. Questions there? No? I'm going to take that as a no. What did I say? 4, -3? Yeah?
Can we go back and do number 4, please?
Yeah, definitely. Let me just throw that in here real quick. Actually, nah, I don't need to. I already checked it. It did. Go back into number 4. Okay, cool. So it's going to be the same idea as the last one we just did. Here you're going to have to decide what you want to get rid of, whether it's the x's or the y's. Personally, looking at this, I think the easier of the two is going to be the x's. It says use substitution. Do you need to use substitution? Would you like to know how? Okay, sure. So if I'm going to use substitution here, I would use this equation by moving this over, which gives me a new equation that reads y is equal to 24 plus 3x. Okay? And then what I'll do is I'll take that other equation, which is 6x plus 3y is equal to -3. And what is y equal to? Well, y is equal to 24 plus 3x, isn't it? So I'm going to take that, and I'm going to plug it in where the y was in the other equation. And then I just solve it for x. So 6x 72 plus 72 plus 9x is equal to -3. So I just use my distributive property at this point. Okay, I'm going to combine the 6 and the 9. That's 15x plus 72 equals -3. Yeah, subtract that 72. That means that 15x is going to equal a -75, which means x is equal to 5, 6, 7, 8. Who do we appreciate? So -5. Now, the nice thing here, Storm, is that we already figured that y equals that, doesn't it? So y equals 24 plus 3 times x, and we found that x is -5. So we're going to take that bad boy, we're going to plug it in here, and then just solve it for y. So 24 plus, it's minus actually, because it was a negative. So minus 15, y is equal to 9. So my solution, the solution I'm suggesting is -5, 9. You plug that back in and you check it, make sure that it's correct.
I was plugging it in the wrong place.
Yeah. One thing that when I was first learning to do substitution, I kept plugging equations back into themselves, and you're gonna just go in circles. Like I literally remember doing pages and pages and pages of it, but I just kept going in circles and circles because of course an equation is going to equal itself, isn't it? No matter what. I mean, it's like saying I got a $5 bill and you just keep folding it up different ways. It's still that same $5 bill. You're never going to get anywhere. Anybody want to see it done with elimination? No? Good. Moving on. Okay, so we had 4, 5, 6, 7, 8, 9. Anybody need 9? Sure or yes?
Yes.
It wouldn't hurt. It never hurt nobody.
Munoz, is our homework on this tonight, or are we learning something new? Please don't let us. I barely get this.
Yeah, give us one more night on it.
Look. I understand that some of this stuff is hard, but I also have to get through a certain number of things. Okay, so we can give you another night. I'd rather go a little bit slow right now than have to go slow the whole time. So I can go a little bit slow right now, so we can go faster later. So we can do this again if you need to. Okay.
Can you do one with the fraction in it?
Hold on. So here, somebody said 9, right? Or did we need 9 at all?
We do.
We do. Okay. So let's. Oh. Now I just stopped and looked at that. These were all divisible by 3 in the second equation. You see that? So if I divide the first number by 3, I get a negative 1x, don't I? And then that's going to give me a positive 4y, and that's going to give me a 4. This equation is simply 3 times bigger than the other equation. Or I should say 3 times smaller since it's negative, which means it's the same equation. So there are infinitely many solutions.
If it's the same equation.
If it's the same equation.
Same line.
Because that means they're on top of each other?
Because there was one with the solution is the empty set on the homework, and then there was one that
Yeah, the empty set would be when they're parallel. Okay? So if like this number was off a little
They
bit.
have the same X and Y.
Yeah, but here you can see they're exactly the same, aren't they? You see it? So that means that they're the same line. Okay, that's why we always say always simplify, because then you see things that way. In this case, I saw that that's the same as the top equation. So it's the same line, infinite number of solutions. Okay? Questions there from anybody? Moving on. Let me clear this. 10? 11?
Yeah.
11. It's okay. I can do it again. Oh, that. Sí, señor, por favor. 2 times, 1 time.
Do a couple of them like this.
Do a couple of them like this.
It's hard.
I think it's just the fractions that are messing with you. Don't let that happen. Try not to let that happen, I should say, because
It's just intimidating.
they are, but it's not really that bad. And what you want to do is try to look at one at a time. Okay. Once we start working, I don't know why we still teach it, but there's a section called complex fractions, and they put fractions inside of fractions inside of fractions inside of fractions, and they're not just numbers; they're algebraic expressions. So it's like not cool. Okay. So don't like the fractions, right? Let's take a look at the top equation. Let's make it twice bigger. Okay, because it's got denominator of 2. So we'll make everything 2 times bigger. So I'm going to multiply this by 2. That gives me 2x minus y is equal to 20. Cool? Second equation, what am I going to multiply by? 9. So that gives me negative 9x plus y is equal to negative 20. Oh, yeah, look at that. Gone. Negative 7x is equal to 0. X is 0. And then y is going to be how much? 5? No, it can't be 5.
0. X equals 10.
Hold on, check my work. Is that correct?
X equals 10.
2 times 10 is 20. That will become a negative
Well,
20.
it's 20 over 9.
But that gives me a negative 7. And 20 minus 20 is... No, that's correct. Now let's plug it into the top one. Let's get x. Oh, yeah. No. If x is 0, that's got negative 1/2. Y is equal to 20. I have to multiply this side by 2, negative 2 to get rid of that. So I'm going to multiply by negative 2 here. That makes this a 1. So y is... no, that's a 10. Sorry. It's the first equation. I try to make a fancy one. So negative 20.
Oh, is it because you put the
Say that one more time. So my solution I'm suggesting is 0, negative 20. Is there any questions on how I came about that? I did that second part pretty fast.
on this one? Why did you subtract it?
Because it says 20 minus 20. Look,
Because 9 and 9 cancel out.
if you look at the top one, I wanted to get rid of the denominators, right? So I multiply by 2. 2 times x is 2x. The 2's are going to cancel there. Not cancel, they make 1, which gives me a negative y. And then 2 times 10 is 20.
Oh, you combined, you did the.
I did elimination. Correct, because it was there. I mean, why not, right? So, we're good there? And you want to do substitution with this, Steve? Did you want to see substitution with this? Okay, so then we're satisfied with this? All right, cool.
It's not even that hard.
It's the fractions. When you look at all that, it's like, like you quit before you started. You shouldn't be scared of fractions. Just chisel away, little by little, patience.
Do you have to do it that way?
How? What were you suggesting?
Can't you use the easy?
Yeah.
Oh yeah, if you. Well, I was doing it because he didn't like the fractions, but yeah. Let me clear this real quick.
And then you find the common.
But yeah, definitely in this case, you could just say, oh look, these are already set up. Bam, it's gone. If you don't mind working with the fractions. So okay, I do need a denominator of what is it, 18? So this is going to become 18, which is twice as big. That was 18. It became 9 times bigger. So that becomes a negative 9. Negative 9 plus 2 is a negative 7. So negative 7y equals. Okay, so I'm going to have 90 over 9 here. So 90 minus 20 is negative 70. Yeah? So negative 70 over 9. To get rid of this, I'm going to multiply by the reciprocal, which is that. Correct? So I'm going to do it over here. 18 negative 7. So that becomes 1y. 7 goes into 70 10 times. 9 goes into 18 twice. And let's see here. So we have 20. Right? Well, why isn't it a negative 20? Oh, that shouldn't be a negative 70. So, negative 20. So, it's the same thing. Math doesn't fail. As long as you do it right, it's going to work. Other questions? Okay. What was that? 11? Anybody need 12? Yeah? I can't hear that very well. Thank you. Yay, slow internet. The first equation in slope-intercept form, so what they want you to do is move them, change them around. So I can actually do this here. I'm going to kick that 4x over. That becomes 3y is equal to 4x plus 1. Divide by 3, divide by 3, divide by 3. So,
Like negative 4x or 4x?
well, it was negative here, and when you move it, it becomes a positive. That's called the change side, change sign.
Yeah.
Okay, so if I'm just picking something up and moving it, then I can just change the sign of it. So here I'm going to, this is going to be a multiple part question.
Yeah.
4 divide 3 forward x plus 1 divide 3. So check answer. Well done. The second equation, well, you can already see what's going to happen, right? We can kind of mimic, and instead of it being a, oh no, we can't. Because that 6 is going to end up being a 3 over it, which is going to be 2, right? I'll just do it. So 3y is equal to 4x plus 6. When I divide everything by 3, y is 4/3 x plus 2. Huh?
Are you ever scared you're gonna like
Nah.
No?
Nah, I've gone hard.
Oh gosh.
I've gone hard on that, and it doesn't punk out. I've gone to a point where it's actually like bouncing off the wall, because it's not. So it's been like,
How's it on there?
huh?
What are you doing here?
Math. I'm doing math all day.
Why would you be writing that hard towards bouncing off the wall?
I was in the zone, okay, and I didn't realize until it was like Mr. Munoz. I'm like, what? But yeah, once you start getting to the bottom, the pressure is what's causing it to bounce. Kind of like when you have a basketball on the floor and you start smacking it, it'll start to bounce eventually. It's the same thing. Check. Math. There's more. Okay, now, actually, here's a good question. Do I even need to do this problem? No, because are they going to have solutions? No. Look at the slopes. They're the same, but they got different y-intercepts, which means they're never going to cross each other. So this has, yeah, and they even ask you, what is it, you know. So I'm going to say, oh, I wish we had null in there, but nah. So we're done. Oh. Did anybody need 13? You guys are okay? Okay, moving on. 14? Huh?
We don't know what that is.
Oh, you want to see what it is?
Yeah.
Oh, okay, my bad.
Yeah, can you do this one?
Yeah, I hope. Train for this. That's that many much math. I'm going to start by editing the top one because of the fractions. What is the common denominator? It's a 6, right? So the whole thing's going to get multiplied by 6. Looking at the first one, 3 goes into 6 twice, so 2 times 1 will be 2x. I'm going to write it here. So 2x, looking at this one, the 6 are going to make 1, right? So that's just negative y. And then 2 goes in there 3 times, so that's that. Oh, well, look at that. Why?
Because it's the same line.
Same equation, same line. So? B.
So
What do the
stop
equations look like
laughing
if
at
there's
me.
no solution?
Just like the last one, they'll have parallel lines. Or when you're trying to solve it as a system, you mean? As an elimination method? You're going to get a false statement. So you'll get something that reads like,
Oh, okay. 0 equals 1.
yeah, so once you get through the whole thing, you'll get something like 5 equals 3 or something. Like, yeah, what? That doesn't make sense. So it's not going to have any solutions. Was there a 16?
I really don't.
That is 15, isn't it?
Yeah.
Anybody need 16? Didn't we just do 15? Oh, we didn't. Solve the system by substitution. Does it have to be substitution? Of course you can. Does this have to be substitution? Who asked for this one? Do you want a substitution or do you want elimination? You want elimination? Okay, so I'm going to try to fit it here.
Wait, so we don't have to do it?
No, if you're just going to plug in a little bubble in there, pick your method. Because all you're going to do is throw this in there, right?
Oh.
Is the computer going to know what you did? Will ACT know what you did?
No.
Will Mr. Munoz know what you did? Yeah, because I'll see your work. But I don't care.
Okay.
Truth is, I don't care. If I told you build me a house, I don't care if you do it by yourself or if you got like 30 people come with you. However you get it done, Actually, I would just throw this in calculator, but. Okay? No? Yeah. Do I see it with the calculator or do I do it by hand? This was Callie's question, so I'm going to let her choose. Callie, I'm sorry. Maria.
What do you want?
What do you want? Okay, alright, let's do this. So, I want it all! There's the first one, and then you got 2x plus 3y is 6. So, I'm going to get this 2 to be the opposite of that. Okay? So, I'm going to multiply it by negative 2. Okay? Because that'll give me a negative 4x minus 6y is equal to negative 12. The beauty now, they cancel out. That's going to give me a negative y is equal to negative 2. So y equals 2. Okay? Pick one of the two. Which one do you want to use to solve for x? Smaller numbers, huh? So 2 times x plus 3 times 2 is equal to 6. Oh, that's 6. And that's 6, isn't it? So 2x is equal to 0, which means X is 0.
Stupid.
That's it. A shot. It's also been immortalized in the Great World of YouTube.
Can you do the calculator way now?
Yeah.
I don't have that time.
We're gonna do 5 with like by hand and the rest.
When you take the ACT, they let you use a calculator, so.
Oh.
What? What's it say? Well, it's not I, it's 1. There's a difference between I and 1. Oh, I for infinite closed solution. Did you put a space in there? Did you go I space accidentally? Okay, screenshot and send it to me.
Can we do 5?
5? Can I do the calculator first? Or
Yeah.
We'll do 15.
Do 15?
Yeah, 15.
Okay. Here we go. Ready? Hidden from students. Why are you hidden from students? Second, matrix. Okay. I'm going to go into the edit so I can change the numbers. And it's a 2 by 3 already. So what I'm going to do is just go down to the first slot, and I'm going to put the coefficients in there. 4, 5, 10. So, yeah, or the bottom, doesn't matter.
It doesn't matter like how they are.
Nope.
As
Yeah, doesn't matter. But since it's in that order, I
does X have to line up with X?
Yes, that is important. They both have to be in standard form. So all the X's have to line up, all the Y's have to line up. If you're doing a 3 by 3, all the Z's have to line up. Okay, so I've got 4, 5, 10, and then 2, 3, 6. And yeah, once you get used to this, it goes by super fast. So I've got my matrix in there. I'm going to quit. I'm going to go back into matrix. I'm going to do some math with that. And I'm going to do RREF, which is option B. Press enter. And then which matrix do I want to row echelon? Which is A. Press enter. And it spits out. So it says 1x is equal to 0, 1y is equal to 2, which is exactly what we had the first time.
So it's
We're done.
So it'd be an ordered pair 0, 2.
0, 2, correct. So it would go X, Y, Z, top to bottom. Or X, Y. No.
So much
The
easier.
easiest.
The reason why we do that, math is not supposed to be about calculating all the time. Math is a process of thinking and finding solutions. Okay? So for a long time, we've had to do those calculations by hand because we didn't have tools to help us do that. But now that we have the tools, we can save time and just let them do the work for us. But doesn't mean you still don't know how to have to do it by hand. Doesn't mean that you still don't need to know how to do it by hand. Okay, because if you're just trusting a calculator all the time, then shame on you. Shame on you. Okay? All right, cool. Other questions? Jacob, you wanted to see another one?
I did 5.
I thought we did 5. No, I don't remember it. I don't remember. How do you want to do it?
I can't get that good at it, so.
You want me to show you all of them then? Just so I can show off.
How fast can you do it?
How fast? Well, if I skip steps, you guys probably won't get it, so. Right? So, I'll just. Actually, no, that's too big. What do you want to get rid of? X's or Y's? Oh, I see what happened. It's out of order.
That's what I was looking at.
You see it? That's why you keep messing up. You should rewrite the second one. It should be X 10y equals 60. Negative 5x plus, sorry, yeah. No, that's not right. Plus 9y, right? Plus 9y is equal to negative 95. So they were messing with you. If you did elimination method. If you were doing substitution, I don't think it would matter. Okay, so let's do substitution. I'm going to kick this over, so it becomes a positive 10y. So that means that 9y minus 5 times 60 plus 10y is equal to negative 95. 9y minus, what is that, 300? Minus 10y is equal to negative 95. Negative y minus 300 is negative 95. Add 300. 0, 205. Yeah?
Yep, sounds right.
So y is negative 205. With what?
Oh yeah, negative 5 times 10.
Negative 5 times 10? That should be, oh, thank you. That should be 50 right here. Thank you. So, negative 50. That means that this becomes negative 49 here. So, negative 49 here. Yeah? Is that correct?
Maybe 41? 41.
Darn arithmetic. Okay, that makes much more sense. That makes much more sense because y would be 5? Negative 5. There we go. And then plug it back into x. So x equals 60 plus 10y. So 60 minus, sorry, plus 10 times negative 5. 60 minus 50 is 10. I just came back to see myself circle that. Alright. ¿Todo bien? ¿Todo bien? Okay. The last one?
Oh.
Oh.
Wow,
Do
I'm
that
dumb.
face one more time.
Oh.
Where's Micah?
I just heard somebody do it. Ebony Perkins compared the monthly payments she would incur for two types of mortgages, fixed rate and variable rate. He observed, led? Oh, her observations led to the graph shown on the right. I'm like, there's an R under the mouse, my bad. Her observations led to the graph shown. For which years would the monthly payments be more for the fixed rate mortgage than for the variable rate mortgage? So, the variable rate, see, for which years is the monthly payment more for the fixed rate? Yeah, so see how this is much higher? From this point to this point, isn't it? So it's going to be from year 0 to year, what is that, 6? Looks like it goes by 2s. Okay, so years 0 through 6. Okay. Okay, that's more, of course. In what year would the payments be the same? In the 6th year. Because that's where they intersect. Okay. What would the payment be in 6 years? Well, I go to 6, jump up there. It looks like it's going by tenths.
Yeah.
So 670. 670. Check. Okay. Are we done?
Yeah.
Oh.
Why?
In my stats class, like when you think you're like here, you're like, okay, we're done. More question. Okay, now we're done. More question. There's like 7 to 10 questions per. Yeah.
It tells you how many cards you're showing on the bottom.
Oh, cool beans. Thanks. I never noticed that.
That's why everyone's saying there's more.
No, I didn't know. I don't stare at this long enough to notice those things.
We do.
Yeah. The only thing I can tell you is like, here's where you can get help. Under the question help. And of course, skipping the question. Yeah, but that's the only thing I care about right here is like, check my answer. That's cool. That's cool.
It doesn't click it. It just like goes through and it says 2 parts remaining. Or 1 part remaining.
But mine doesn't have a number.
No, because you're done.
Oh. I'm gonna have to check that for stats. Thanks. That's it. We're good. All right, cool. We got 20 minutes. Let's do the next section. Just kidding. No, I want to show you how to do these things on the calculator. Okay, everybody should be able to do them on the calculator, right?
I just don't know how to get it where it'll solve it for you.
Okay, then take these notes. Okay, let me clear this. You know how to put it in.
Can you open up my homework?
I haven't done it yet, but I will.
Yeah.
Okay, ready? Second matrix. Yeah, edit is where you're going to enter it, so we're not going to worry about that. You're good with that. Okay, so what you want to do now is you want to math. Okay. Well, let's say you are in edit mode. Let's say you're here already and you have it done. You're going to go second and then quit, so you're at the home screen. Because this is where you do all your mathy stuff. Okay? Well, that's what I'm going to do next. See, he's doing it. He's following me, so I'm going to wait for him, okay? So now I'm going to go second matrix, and I'm going to go over to math. Push up. It just jumps faster, and you want to get to B, which is RREF. Not REF, RREF.
If you go to REF, will you get a different answer?
No, but it won't be done. The difference between REF and RREF, like remember I told you about the row of ones?
Yeah.
And this would be 0, this would be 0, 0. With REF, you could still have values like 5, 2, 3 there. So reduced row echelon, what that does, it makes it so that you can see what the answer is. So the only answer you actually get is the last one, and then you have to plug that into this one, get an answer, plug it into this one, get an answer. Okay? If you're doing it by hand, this is enough. And that's why we have REF, but with a calculator, we take it a step further. Yeah, hit enter, it'll say this. So now just tell which matrix you want to reduce. So, and that's in the name. So just go back in there, in names, the first menu. Yeah. Everything's in matrix.
And then press enter again.
Yeah, because I want row A, right? Or matrix A. If it was B, I would go over to B. But I want A. Push enter. Should look like that. Enter one more time.
It would just be the top one and then the bottom.
Well, here, this is the way you would read it. See how this is the X column? 1X is equal to how much? And this is the Y column, so 1Y is equal to?
So it's 0, 2.
Correct. X, Y, Z, top to bottom. Cool? Alright, stopping this.